Welcome dear students, welcome to Kreatryx channel, welcome to Unacademy and welcome to Impulse batch. Before going to start the topic, let me introduce myself. I am KV Swami. I did my MTech in Systems and Signal Processing from JNTU College of Engineering, Hyderabad and passed out in the year 2007. And since 2009, I was into this GATE coaching field, teaching my favorite subjects, signals and systems and communication systems throughout the country. I have a total of 12 plus years of teaching experience. Now I am associated with Unacademy, and if you want to purchase any course on Unacademy, you can happily use my code KVS Live, with which you will be getting flat 10% discount. Any course on Unacademy you can take using my code KVS Live. First of all, we'll observe what are the courses for GATE we are having in Unacademy. Basically, we are having two types of courses. The first one is called the Plus subscription and the second one is called the Iconic subscription. So in the Plus subscription, the student is exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the class in Hindi, and if a student is not comfortable with Hindi, he can take the class in English from his choice of educator. And we have rank improvement batches also. Apart from this, we have one more subscription known as Iconic subscription, in which the student will be under the supervision of an experienced educator known as mentor. So in Iconic subscription, a personal coach is given to the students, study planner is given, study booster sessions are there, personal test analysis is taken, and doubt clarifying instructors are there, and preparatory study material is also given. Now let's look at the fee structure in the Plus subscription and Iconic subscription. If a student is planning for GATE or ESE preparation for 12 months, that is 1 year, in Plus subscription it costs around 27,225 rupees only using the code KVS Live. You can use the code KVS Live. If you are going to use the code KVS Live, you are going to get the course for 27,225 rupees only. And if a student is preparing or planning his journey for GATE or ESE for 18 months, that is a 1.5 year course, in Plus it costs around 34,650 rupees only using the code KVS Live. Now if a student is planning GATE or ESE journey for 24 months, that is 2 years, for 2 years if he is planning, in Plus it costs around 39,600 rupees only, and you can use the code KVS Live. Coming to Iconic subscription, so in Iconic subscription, GATE or ESE preparation for 12 months, that is 1 year, it costs around 45,225 rupees, and you can use the code KVS Live. And GATE or ESE preparation, if a student is planning for 24 months, that is 2 years, see it costs around 66,600 rupees, and you can use the code KVS Live. And the second year plan, either in Plus subscription or Iconic subscription, is ideal for second year students. This is ideal. 2 year plan is ideal for second year students. So whatever may be the course in Unacademy, feel free to use the code KVS Live to get maximum discount. Right, now let's switch back to our topic. Those who are coming new, please subscribe the channel and share the channel. Good morning Harish, Manu, Adarsh, all of you people, you share the channel, and all of you type your attendance by pressing the like button. Okay, all of you must type your attendance and you must share the session. Right, if you recollect from yesterday's discussion, yesterday what we were discussing, we were talking about discrete time. Let me recollect the basics of yesterday's class. What we were discussing something about discrete time basic signals. Okay, this is our topic. So what we have seen in discrete time basic signals, my dear students, first one is discrete time unit impulse. discrete time unit impulse signal we have seen. Hope you remember the definition denoted by del n, defined as 1 at n is equal to 0 and 0 for n not equal to 0. And this is the shape of discrete time unit impulse. And what is the importance of this signal? I said any discrete time signal can be represented in terms of this impulse signal like this by using this expression xk del of n minus k. And after looking at this, we have seen the properties of, good morning Jyoti, the discrete time unit impulse. What are the properties? So area under discrete time unit impulse signal is 1, and the second property is del of kn is what? Del of n. Unlike continuous time impulse, in continuous time what happened? Del of at is 1 by mod a del of t. In discrete, del of kn is del of n only. And the third property also we have seen, x of n into del of n minus n naught is equal to x of n naught into del of n minus n naught. And after this we have seen the last one, property integral minus infinite to infinite x of n into del of n minus n naught is equal to x of n naught. One example also we have solved. If the shift n naught lies between the summation limits, simply substitute the value of shift in the signal. Right? So this is about discrete time unit impulse. After that we have seen discrete time unit step. Till the strength gets accumulated, I will be discussing the yesterday's topics. Discrete time unit step signal we have seen. Okay, discrete time unit step, first of all denoted by un. How we are going to define? 1 for n greater than or equal to 0 and 0 for n less than 0. So what is the shape? This is the shape. This is u of n. Now after defining, we have drawn what is known as u of n minus 1, and we got the relationship between impulse signal and step signal, discrete time unit impulse signal and discrete time unit step signal. What is the first relation I told you? You must remember u of n minus u of n minus 1 is nothing but del of n. This is the first relation I told you. And what a name we gave for this one? First difference. First difference. First difference of discrete time unit step produces discrete time unit impulse. And what is the other relationship? Summation k varying from 0 to infinite del of n minus k is equal to u of n. This is the second relationship we have seen. This is what is known as your summation or accumulation, which is similar to integration in continuous time. Right? After looking at these two, we have seen something known as u of n plus u of minus n minus 1. What is this equal to? 1. U of n plus u of minus n minus 1 is 1 in discrete. In continuous, u of t plus u of minus t is 1. In continuous, u of t plus u of minus t is 1, whereas in discrete, u of n plus u of minus n minus 1 is 1. You have to remember this one. And one more thing also, I ask you to verify whether it is true or false. U of n plus u of minus n, whether it is equal to 1 plus del n or not. Yes, it is true only. It is true only. I think we have seen up to this point, and we have solved some examples also. Right? Hope this is clear for all of you. And we have seen the scaling property, what happens if you scale a discrete time unit step, and what happens if you take the reversal, and all that we have seen. Now let me continue with today's class. Right? So today's class is very important and interesting even. Yesterday I gave you some homework. I asked you to draw the shape of the signal. This, I think I gave you the first one like this: u of n minus 1 minus u of minus n minus 1. What is the shape of this signal? So as we are in early stages, let's proceed step by step. Now two signals are there. First one is u of n minus 1, second one is u of minus n minus 1. Do you know about u of n minus 1? How to get u of n minus 1? Start with u of n and go to u of n minus 1. U of n means exists from what value to what value? 0 to infinite. U of n minus 1 means 1 to infinite. Delayed version, no? Now u of minus n, what is the journey of u of minus n minus 1? Lot of interesting things are going to come in today's class. All of you must listen carefully, my dear students. U of minus n minus 1. How to draw this one, or what are the limits? First shift then scale. So u of n is there with you. Go to u of n minus 1. Call this as y of n. Scaling by minus 1 is equivalent to reversal. U of n means exists from 0 to infinite. U of n minus 1 means exists from 1 to infinite. So these are the limits for y of n. Y of minus n means minus infinite to minus 1. Now u of minus n, remember my dear students, u of minus n minus 1 is a signal coming from minus infinite to minus 1. Now let's draw the signal. So discrete time signal, no, make the independent variable ready. Make the independent variable ready. Independent variable is n, 0, 1, 2, 3, 4. Yes, I'll upload, Venkatram. Yesterday I have not uploaded, but today I'll upload yesterday's class and today's class. Every class will upload. Now this is our signal x of n. Now how we are going to draw? First of all, as we have seen the analysis for u of n minus 1, let's draw. U of n minus 1 means 1 to infinite with a value, unit step, no, so it goes with a value of 1. Very simple, very simple. Okay, done. Right, now second part is what? U of minus n minus 1. U of minus n minus 1 is a signal existing from minus infinite to minus 1 only, but here minus symbol is there. Minus symbol means amplitude reversal. This is the shape of the signal. Hope all of you got this, the shape. Hope all of you got the same shape. Yesterday's homework problem. I'm asking you to draw the shape of the signal. Hope you got the same answer. If you're not getting the same answer, please verify once. If you're getting mistakes, no problem. With practice, everything will go. But without practice, you cannot correct your mistakes. Let me tell you that. Right. So this is the first one. Second one. What is the second one? I think I gave you this one. U of n minus u of minus n. Right. Now let's analyze the signal. U of n means what? Do you know about u of n, my dear students? U of n means it exists from 0 to infinite with a value of 1. Right? Discrete time unit step. U of minus n means what? Do you know? Time reverse version exists from minus infinite to 0 with a value of 1. So let's draw. Let's draw and verify. Today a lot of interesting things are going to come. This is u of n. Right? Now let's draw the other signal. What is the other signal? U of minus n, but minus is there. So take the amplitude reversal for that. So u of minus n means exists from minus infinite to 0, but here minus symbol is there, no? So minus means take the amplitude reversal. Right. Now what we have to do? or I can simplify for convenience as I can write this as like this also. So u of n I have drawn minus u of minus n. Now what I have to do? I have to add. Addition is very easy. Right, what happens if I add? At 0, what is this value? 1. At 0, what is this value? Minus 1. 1 plus minus 1 is 0. At 1, this value is 1, this value is 0. The signal is absent. For n greater than or equal to 1, the bottom signal is absent, so that the resultant signal you are going to get like this. Now, at minus 1, the value of the bottom signal is minus 1, the top signal is 0. Like this you are going to get, right? So this is your signal. Now if you observe, the first one, this one and this one are same. Both the signals are same. If you observe, my dear students, both the signals are same. And sir, what happens if we perform subtraction? Subtraction also will get the same answer. Chinna, you'll get the same answer. Don't worry. You practice, Chinna. Everything comes with practice only. No shortcut. Observe here. So the first signal what I gave and the second signal what I gave are same, and this is nothing but our basic signal, third basic signal in discrete. It is nothing but signum function. Signum function in discrete. See, signum function in continuous we have seen, right? This is signum function in continuous. Yes or no? Signum t. Hope you remember. How we define that? How we define 1 for t greater than 0, minus 1 for t less than 0. At 0 we have a sudden rise which is known as discontinuity. According to Gibbs phenomena, take the average of the values. This is in continuous. In discrete, signum. First, so the next basic signal is signum. Signum function. Signum function. First of all, let me draw the shape. Third time I am drawing the shape. This is signum function. Signum of n. First of all, first point, how you are going to get signum from unit step signals in two ways. First way is signum of n can be obtained as, we have done one experiment, no? U of n minus 1 minus u of minus n minus 1. This is first, this is one form. Second form, signum of n can also be obtained like this: u of n minus u of minus n. And what is the definition of signum you are going to give? Signum of n can I define like this: 1 for n greater than or equal to 1, 0 at n is equal to 0, and it is minus 1 for n less than or equal to minus 1. Can I write like this? Yes. So this is the definition of signum. Hope this is clear for all of you. Nothing is there, no rocket science. Signum function in discrete. Continuous we have seen. Now this is a discrete counterpart. Okay. Signum of n. After this is completed, I want to switch to the next basic signal in discrete, which is nothing but our ramp signal in discrete. In continuous we have analyzed ramp signal like anything. In discrete, R of n. How we are going to define it is n for n greater than or equal to 0 and is 0 for n less than 0. It is n for n greater than or equal to 0 and 0 for n less than 0. Now how you are going to draw? I have given you the definition. N greater than 0, it's better to put n greater than or equal to 0. So I have given you the definition. Take the independent variable n. Why independent variable n? Because discrete time signal 0, 1, 2, 3, 4. At 0 its value is 0. At 1 its value is 1. At 2 its value is 2. At 3 its value will be 3. Linear relationship, no? At 4 its value will be 4, and so on. This is your ramp signal, R of n. R of n. Now if you remember, in continuous case we have written R of t as tu of t. In continuous case, if you remember, we have written R of t as tu of t. In the same way, we can write in discrete case R of n as nu of n. Nu of n. Important. R of n is nu of n. Jayatita, you have to put equal to n greater than equal to 0, because if you don't put what is the value at 0, n greater than 0, n less than 0 means what about 0? Problem will come. Remember, R of n can be written as nu of n. Important relation. Now my question is how to get u of n from R of n. How to get u of n from R of n? Can I get a unit step signal from a ramp signal? In continuous case, how to get? In continuous case, how to get d by dt of R of t if I have differentiate u of t. In discrete case, how to get u of n from R of n? Yes, Chaitya, you can write, no issues. How to get u of n from R of n? Any idea? Remember, u of n is nothing but first difference will give shifted step. Okay, shifted step, yes. So do one thing, u of n is R of n plus 1 minus R of n, you try. U of n will be R of n plus 1 minus R of n. This will work. R of n plus 1 minus R of n. Hope this is clear for all of you. R of n plus 1 minus R of n is U of n. Sigma k is okay. Now look here, Jetida, you are saying something, but look here. I said that what is the importance of impulse signal? Any signal can be represented in terms of impulse signal, no? So how I gave you the expression. What is the physical significance of this expression? We will discuss in the third unit. Now, any signal can be represented in terms of impulses like this. Yesterday we tested whether this is working or not. U of n, substitute U of n, so that summation k is equal to 0 to infinite del of n minus k. It is working. Today let us test with R of n. R of n means limits exist from what value to what value? 0 to infinite. Between 0 to infinite, what is the value of R of k? R of k means k only, linear relation, no? Del of n minus k. Now what happens if I plot this one? What happens if I substitute k is equal to 0? What happens if I substitute k is equal to 0? 0. K is equal to 1, del of n minus 1. Del of n minus 1 is delayed version of del of n by 1 unit. K is equal to 2, you substitute. 2 del of n minus 2. 2 del of n minus 2 is delayed version of del of n by 2 units, but amplitude scaled by 2. 3 del of, what happens if I substitute k is equal to 3? 3 del of n minus 3. And after that 4 del of n minus 4. And so on. This is nothing but R of n only, right? Yes, this is working. Right? So your ramp signal can also be written in terms of impulse signals like this. If anybody asks you how you are going to write a ramp, how you are going to write your ramp signal in terms of impulse signal, means you must explain with this one. How you are going to write your ramp signal in terms of step signal means nu of n. Nu of n. What the definition of ramp signal means? This one. Right? Okay. Now, if you are comfortable with this, I want to give you an example. Important example. Take the example. I am giving you a signal. Zero, 1, 2, 3, 4, 5, 6. At 1 its value is 0. At 2 its value is 4. At 3 its value is 6. Sorry. Now this is my signal x of n. Now try to represent this signal x of n in the forms what you know. In whatever the forms you know, try to represent this signal x of n. How you are going to write the expression for x of n? How you are going to represent x of n? All of you try. All of you try. Jayatita, try using give different values, and if you are going to get the same, no issues. One signal can be written in multiple forms. Even if I can represent the discrete time unit impulse using ramp signals also. You can represent, no issues. Put it on paper. If it's coming out to be correct, you can represent. Now the question is, try to represent this signal in all the available forms. All the available forms means first in initial classes what we studied, discrete time signals are represented as sequences. So in sequence form I can represent. So how you can represent? 0, 0, 2, 4, 6, 0, 0. Sorry. Can I represent like this? Can I represent like this? Here, what is the sample value at 0? 0, 1, 0, 2, 2, 3, 4, 4, 6, 5, 6, 6, 6. This is one representation what we know. Second representation. You can write this in terms of impulses. How you are going to write in terms of impulses? Impulses. So at 0 nothing is present, at 1 nothing is present. At 2 we have an impulse of value 2. So 2 del of n minus 2 plus 4 del of n minus 3 plus 6 del of n minus 4 plus 6 del of n minus 5 plus 6 del of n minus 6. Can I write like this? Okay, Manu will verify. We haven't reached up to ramp, but we are in basics now. First representation is using a sequence. Second representation using impulse signals. Hope you are all comfortable with the first and second representations. Right. Now the third representation is, can you represent this x of n in terms of step? Now if you observe, look here, at 2 we have a sudden rise. Sudden rise you can consider like this. In order to write in terms of steps, you can put the dots like this. At 2 we have a sudden rise going with a value of 2. When it reached the point 3, its value became what? 4. Means a value of 2 must be added. Again, as this is going with a value of 4, when it reached the point 4, its value became 6. Means one more value of 2 must be added. As this is going with a value of 6, when it crossed 6, that is when it came to the point 7, its value became 0. So a value of 6 must be subtracted from this 6 so that the resulting signal will become 0 at 7. Now can you write in terms of unit steps? Yes, I can write. Look here, put the dots for convenience like this. Now how you are going to write? 2u of n minus 2. 2u of n minus 2 is a step signal starting at 2, going with a value of 2. As this is going with a value of 2, when it encountered the point 3, its value became 4. Means what value must be added? A value of 2 must be added. At what point it must be added? At a point 3. 2u of n minus 3. Right. Now this is going with a value of 4. If I add these two, the resulting signal is going with a value of 4. As this is going with a value of 4, when it encountered the point 4, its value became 6. Now what value must be added to 4 to make it 6? A value of 2 must be added. 2u of n minus 4. At what point? 4. As this is going with a value of 6, now when it encountered the point 7, its value became 0. So what value must be added to 6 to make it 0? A value of minus 6 must be added. At what point it must be added? At 7. Now I'm able to write my signal x of n in terms of step signals also. Hope you're all comfortable. Please verify. First of all, in the first step I have drawn the signal in terms of a sequence. Second representation is using impulses. Third one is using step signals. Right? Now, can you represent or can you write this signal x of n in terms of ramps is the question. In terms of ramps is the question now. Now, for that you can do one thing. Do you know the relationship between ramp signals and step signals? Yes, just now we have seen that r of n plus 1 minus r of n is u of n. Just now we have seen this relation. Now if I want to get u of n minus 2, so I'll write like this. Observe here, my dear students, u of n is nothing but r of n plus 1 minus r of n. Suppose if I want u of n minus 2, replace n with n minus 2, what will happen? N minus 2 plus 1 minus r of n minus 2, or u of n minus 2 can be written as r of n minus 1 minus r of n minus 2. Right? Isn't it? In the same way, how we are going to write u of n minus 3? In the place of n, here in the first expression substitute n minus 3. What will happen? R of n minus 2 minus r of n minus 3 will come. In the same way, u of n minus 4, how we are going to write? With analogy you can write r of n minus 3 minus r of n minus 4. In the same way, u of n minus 7, how we are going to write? R of n minus 6 minus r of n minus 7. Simple basics. Now after that you try to substitute u of n minus 2, u of n minus 3, u of n minus 3, u of n minus 4, u of n minus 7 in this expression and see what you are going to get. So let's verify. So x of n is equal to 2 times u of n minus 2. U of n minus 2 means r of n minus 1 minus r of n minus 2. R of n minus 1 minus r of n minus 2. Okay, minus, I think it is plus u of n minus 3. U of n minus 3 means what? R of n minus 2 minus r of n minus 3 plus 2 times, what is there? U of n minus 4. U of n minus 4 means what? R of n minus 3 minus r of n minus 4. Now the last term I don't want to touch. You can write, but I want to keep in terms of unit steps only. Why I am going to keep, I'll let you know later. Now 2r of n minus 1, 2r of n minus 1. If you observe, minus 2r of n minus 2 plus 2r of n minus 2 gets cancelled, and here what I am going to have, minus 2r of n minus 3 plus 2r of n minus 3 gets cancelled, minus 2r of n minus 4 minus 6 u of n minus 7. Yes, I am able to put the signal in the third form, that is using ramp signals and step signals. Hope you are all comfortable with this. Manu, you can verify your answer once. Now observe here, in the first case what I written in terms of sequence, very easy, child's play. Second one in terms of impulses, third one in terms of steps, fourth one we have written in terms of ramps and steps. Now the question is, can you write this expression directly without all this analysis what we have done? Can you write this expression directly? Yes, we can write, but let me draw the signal one more time for your convenience. 0, 1, 2, 3, 4, 5, 6. At 1 value is 0, at 2 value is 2 now, at 3 value is how much? 4, at 4 value is 6, at 5 value is 6, at 6 value is 6. Now this is the signal. Now my intention is to write this signal in terms of ramps and steps, but within a single step I want the result. Yes, I can write. Observe here. Now the signal is starting at what point? See, if you want to write in terms of ramp, see, at 2 means you need the point 1 also. If you want to write in, see, because ramp means it will grow linearly, right? So if you want to start at 2 means you need the point 1 also, and if you want to end at 6 means you need the point 7 also. Now how you are going to write? Now ramp means slope, we want slope. If you are trying to calculate the slope, here slope means what? Vertical by horizontal. Here what is the width? 1 unit. What is the height here? What is the height? 2 units. So slope is 2. Now again draw dots in linear fashion. Now from 2 to 3, see what is the slope here? Slope is 2. Observe here, vertical by horizontal. Here also vertical is 4. Here from 2 it is going to 4, means slope is 2. From 4 it is going to 6. In what duration? In duration of 1 unit, means slope is 2. Now from 6, if you observe, what happened to the slope? Slope is 0. It attained some value 6, right? Now can you write in terms of ramp signals now? Observe here, my dear students. See, starting at 1, going with a slope of 2. Starting at 1, going with a slope of 2 means what could be that signal? Starting at 1, going with a slope of 2 means ramp signal. Starting at 1, going with a slope of 2, 2 r of n minus 1, because from 1 to 4 if you calculate the slope it will be 2. So 2 r of n minus 1 is a ramp signal starting at 1, going with a slope of 2. As this is going with a slope of 2, when it encountered the point 4, what happened to its slope? 0. Now you tell me, what slope should be added to 2 to make it a slope of 0? A slope of minus 2 must be added. At what point it must be added? At the point 4. So what is the equation of the ramp signal? Starting at 4, going with a slope of minus 2 r of n minus 4. Now if I add this signal and this signal, resulting slope will become 0, but it will attain some value. Now the resulting signal is going with a value of 6, but that value must be made 0 from what point? From the point 7. So what value must be subtracted from 6? To make it 0, a value of 6 must be subtracted. At what point? At the point 7. So what is the expression of that signal? So value 6 must be subtracted starting at 7. Now if you observe, same expression we got. Same expression, you can verify. Same expression we got. first of all, if you want to write in terms of ramp using dots, you can trace the signal like this. Calculate the slope. Slope is 2. Starting at 1 means 2r of n minus 1. Right? At 4, if you observe, slope became 0. Slope became 0 means a slope of minus 2 must be added. At what point? 4. Minus 2r of n minus 4. Now this is going to value of 6. That value of 6 must be made 0 from 7. So subtract a value of 6. Minus 6u of n minus 7. Hope this is clear for all of you. If you solve one more problem, we'll get confidence. Let's take one more problem. Right. Try to write the signal in terms of ramps. Try to write the signal in terms of ramps. Steps you can write. See, if you have any difficulty in writing the ramps directly, first of all represent in terms of steps and then go for the ramp representation using the relationship between u of n and r of n. That you can do. We'll do one thing. First of all, in sequence notation you can write. In terms of impulses you can write. Not a big issue. Now let's start with steps. Steps, how you are going to write? So minus 2. Starting at minus 2, going with the value of 2 means what is that? 2u of n plus 2. As 2u of n plus 2 is a step signal in discrete. Starting at minus 2, going with the value of 2. As this is going with a value of 2, when it encountered the point minus 1, its value became 4. Means value of 2 must be added. Okay. Now if I add, what will happen? The resulting signal is going with a value of 4. But when it encountered the point 0, its value became what? 6. Means add a value of 2u of n. At 0, no? 2u of n. Now this is going with a value of 6 now. As this is going with having a value of 6, when it encountered the point 1, its value became 4 again. Means from subtract a value of 2. But at 2 its value became 2. Subtract a value of 2 one more time. 2u of n minus 2. Now the resulting signal is going with a value of what? 2. But at 3 it must be made 0. Right? So now you have the relation, right? You can substitute here. You can substitute and you can verify whether you are going to get the signal in terms of ramps or not. Now the next method is what? No sir, I want to write directly. Yes, you can write, but in terms of ramps you have to calculate the slope. So using dots, try to frame or arrange your signal in terms of ramps like this. Right. Now the next thing is calculate the slope. Slope means what? Vertical by horizontal. Here slope is what? Vertical 2 units, horizontal 1 unit. Slope is 2 units. Here you can observe from 2 it is going to 4. Means vertical change is what? 4. Sorry, vertical change is 2. Horizontal change 1. So slope is 2 from here. Slope is 2. Right here you can calculate the slope, it will be minus 2. Now can you write in terms of ramps directly? Yes, I can write. How? Slope to starting at what? From here we have to start. Ramp signal is from here we have to start. So slope to starting at -3 means what is that? 2r of n plus 3. 2r of n plus 3 is a ramp signal starting at -3 going with a slope of 2. As this is going with a slope of 2, if you observe, when it encountered the point 0, its slope became what? -2. Slope became -2 means what slope should be added to 2 to make it a slope of -2? A slope of -4 must be added. At what point it must be added? At 0. So slope of -4 starting at 0, -4r of n. Now if I add, the resulting signal is coming with a slope of -2, but at 3 it must be made 0. So what slope should be added to -2 to make it a slope of 0? Slope of +2 must be added. At what point? 3. 2r of n minus 3. Verify whether you got this 2 Jaitirtha, 2r of n plus 3 minus 4r of n. Plus will come, Jaitirtha. You have to verify. You must be very careful. Plus will come. Finite duration signal, when you are representing only in terms of ramps, if you add all the coefficient, it must result in 0. In your expression, if you add all the coefficient, it is not resulting in 0. Jaitirtha, please verify. Verify for once. Okay, typo error. Very good, very good. In your leisure time, do one thing. You try to write this signal, what we are written in terms of steps, try to represent in terms of ramp and see whether you are going to get this expression or not. That will be a practice for you. Right? Now we are able to write our discrete time signals also in terms of ramp. Okay, very fine, good. Let me tell you one thing, my dear student, that this Sunday we are having a marathon session on the basics of signals and systems, in which I am planning to give you around 50 questions on completely pure basics. If you are able to score good marks in that small quiz or test, your basics are perfect. You can answer any question. If you are able to solve those 50 questions, confidence will come like anything. So don't miss that marathon session on Sunday. Anyway, on Saturday I'll announce the timings and all. Fine. Now, timings I'll let you know. Most probably 6 to 9 I'm planning. Morning 6 to 9. Okay, take down this signal, all of you. For that test, all the basics we have seen from the first class, you must study and come. Then only you can solve. One discrete time signal is given to us like this, x of n. From this, he is asking us to calculate some quantities. First one is x of n minus 3. Second one is x of 3 minus n. Third one is what? X of 3n. Fourth one is x of 3n plus 1. Because we haven't seen the transformations of the independent variable example in discrete. Continuous case we have seen many. Now I want all this from the signal x of n. Deepak, for basics you go through all the lectures of our or you can go to the playlist. You'll get each and every basic. Now from this discrete time signal x of n, I want all this a, b, c, d, e. How you are going to get? First one, x of n minus 3. Is there any need to draw this one, x of n minus 3? No need to draw. So from x of n, directly you can go to x of n minus 3. You can do analysis. X of n minus 3 is in the form of x of n minus n naught, time shifting operation, where n naught is 3, which is positive. So in time shifting, n naught positive means what? Delayed version or advanced version? Delayed version. Right shift or left shift? Right shift. By how many units? 3 units. So x of n exists from minus 4 to 3, whereas x of n minus 3 will exist from what value to what value? Delayed version by 3 means minus 1 to 6. You can draw simply shift right the given signal by 3 units. Very easy question. No need to draw first one. Just to boost your confidence, I given the first one. Second one, x of 3 minus n. Let's draw. You have to draw this one. X of 3 minus n. How you are going to draw? First of all, arrange this in the form of x of minus n plus 3. What do you know? This is a transformation involving shifting as well as scaling. First shift, then scale. Don't hesitate to draw, because without practice nothing is going to come. So first shift, then scale. I'll be drawing. You can verify your answer whether you are going to get the same or not. X of n is there with you. X of n plus 3. X of n plus 3 is what? Advanced version, no? Advanced version means left shift. For this one, take the reversal. My dear students, let me tell you, tomorrow's class is very, very important, because we are going to discuss even signals and odd signals in detail, in which you will get a lot of information, lot of hidden things you are going to know. Please verify whether you got the same answer or not, all of you. Please verify. You must draw parallelly with me, otherwise simply listening the class makes no sense. Numerically based subject means you have to solve along with me. No sir, by looking at the video I can understand means definitely will commit mistakes. So this is the second one. Hope you all got the same answer. So second one is also completed. First shift, then scale. Third one, x of 3n. X of 3n. Directly you can draw. X of 3n means, what is this one? X of 3n, if you try to analyze this one. So let me erase this part. X of 3n. What do you know about x of 3n? If you try to recollect your basics, this is in the form of x of alpha n, scaling. So here alpha is what? 3. Alpha is greater than 1 means in discrete what will happen? Decimation will happen. Decimation. For a finite duration signal, decimation will happen. Decimation means what? Decrease in number of samples. And what is the other name for decimation? Downsampling. Downsampling. And what did I tell you how to decimate a signal? See, first of all, observe the decimated factor. So to the right and left of 0, to the right and left of the point 0 on the horizontal axis, skip alpha minus 1 samples. Skip alpha minus 1 samples. So directly you can write alpha minus 1 sample. Means the sample at 0 will come. It will come. After that this will come. You neglect this one. Alpha minus 1. Alpha is 3, no? Alpha minus 1 means 2 samples you have to neglect. These 2 samples. Again this will come. Okay. This will come. To the left also perform the same. This will not come. You have to neglect how many samples? Alpha minus 1 samples. Neglect. Now this will come. This will come. After that you have to neglect 2 samples. So this will not come. So this must be your answer. In samples also you can represent. If you are interested, you can represent in terms of impulses. If you are interested, you can represent in terms of steps or ramps. Your wish, Jaitirtha. Try to take it as exercise. Try to represent this signal in terms of ramps and verify. Your wish. You can play with the signal. If you know the basics, that's what I am saying. If you know the basics, you can play like anything. Try to represent this in terms of signum. Your wish, your wish. All this kind of experiment will try to perform on Sunday. You'll enjoy like anything. 3-hour session on complete basics only. So this is x of 3n. Hope you're all comfortable with x of 3n also. X of 3n plus 1. Right, x of 3n plus 1. X of 3n plus 1. Now x of 3n plus 1 is, this is a transformation involving shifting as well as scaling. First shift, then scale. What is the path? First shift, then scale. X of n is there with you. Go to x of n plus 1. Call this as y of n. X of 3n plus 1 will come, isn't it? Right? Now x of n is there with you, x of n plus 1. So x of n plus 1 means this is y of n. Now y of 3n I want. Y of 3n means what? So neglect these two. Decimation I am doing. Include these two. Neglect these two. Simple, one step. 0th sample will come like this. And this sample will come, minus 3 sample will become the samplet minus 1, 1 by 2. That's it. That's it. Jaitirtha 0, 0.510. Okay. Only 2 samples you are going to get. Jaitirtha 0.1. Jaitirtha verify. 0.1 only you are going to get. Or I committed any mistake? No. Only 0.1. Verify Jaitirtha. Okay, fine. So my intention here, my intention in discussing this particular question x of 3n plus 1 is something different here. Observe here, x of 3n plus 1 if you are given. Just now we have seen first shift then scale. First shift then what happened? Buffering problem. So first shift then scale we have seen. What happens if you go by first scale then shift? Because two methods we have. First scale then shift if I go. And I told you that if you want to first scale then shift, you have to take alpha as common. You have to take alpha as common. And what is the path? X of n is there with you. Go to x of 3n, first scale, then shift. If here plus is there, plus means advance, we know, by 1 by 3. Now the question is it possible? Is it possible to advance the discrete time signal by 1 by 3? No. No. So this method called first scale then shift failed. First scale then shift failed in this particular expression. Now suppose if you have, instead of x of 3n plus 1, suppose if I have x of 2n plus 4. Now we'll see whether first scale then shift will work or not. So for first scale then shift, taking alpha as common is mandatory. Now you can scale a discrete time signal by 2 units and you can advance a discrete time signal by 2 units. Yes, it will work. First scale then shift will work. So in the first case, in our example, it got failed. But if I take, instead of 3n plus 1, if I take x of 2n plus 4, it is working. Suppose if I take x of 3n plus 3n minus 5. Now we'll see whether it works or not. 3 times n minus 5 by 3. So you can scale a discrete time signal by 3 units, but you cannot delay a discrete time signal by 5 by 3 because discrete time signals exist only at integer values of time. You cannot delay a discrete time signal by 5 by 3. So again it got failed. So there is no guarantee that in discrete case first scale then shift works for every time. Remember what I am saying. There is no guarantee that in discrete case first scale then shift works every time. It works for some time, it fails for some time. So you must observe the relationship between alpha and beta. Alpha and beta. So why to take again multiples? We have to see, a lot of discussion will come. So in order to avoid that, so whenever you are given these kind of transformations in discrete, go with first shift then scale only. You won't have any problem. First shift then scale. It will work every time. First shift then scale works every time. So if you are going for first scale then shift in discrete, I am talking about. In continuous, first scale then shift, first shift then scale will have the same effect. They won't fail. But in discrete, so first scale then shift will fail sometimes. So better to go with first shift then scale. Better to go with first shift then scale, my dear students. Anyway, I'll be discussing all this in the revision part. Don't worry. Don't worry. So in discrete, there is no guarantee that in every case first scale then shift works. It works for some time, it fails for some time. So in discrete, always whenever you have combination of transformations, go for first shift then scale. First shift then scale. That is my intention. Hope you understood my intention. Yes, it can be neglected, Jaitirtha, no problem. Neglected, you simply neglect that. Right. Jaitirtha, you can neglect. So 0.5 and 1 is the answer. Right. The last one. So what was the last one? X of n multiplied with u of 3 minus n. X of n multiplied with u of 3 minus n. Now how to get this one? Look here. I'll erase this. Fine. Observe here. X of n multiplied with u of 3 minus n. Now in a logical way I'll try to solve this one. X of n is a signal existing from what value to what value? X of n is a signal existing from what value to what value? If you observe, -4 to +3. -4 to +3. Of which it has different amplitudes. -1, -1/2, 1/2, 1, 1/2. So it has different amplitudes. Different amplitudes I'm going to have. U of 3 minus n. Can you tell me? U of 3 minus n is a signal existing from what value to what value? U of 3 minus n is a signal existing from what value to what value? If you don't know, if you forgot also, no problem. Again you can verify, because U of 3 minus n means first shift then scale you can apply. U of 3 minus n can be written as U of -3 plus n. Sorry, -n plus 3. -n plus 3. First shift then scale you apply. U of n is there with you. Go to U of n plus 3. From which you go to U of -n plus 3. U of n means 0 to infinite. Exactly, Manu. U of n plus 3 means -3 to advanced version, -3 to infinite. U of -n plus 3 means -infinite to +3. No issues. If you forgot also, we can get the answer. Now -infinite to +3. Okay, fine. Of which unit step, no, unit amplitude. Only unit amplitude will be having. Now multiplication must be required. So X of n multiplied with U of 3 minus n. And what do you know about multiplication of signals? Multiplication of signals is nothing but multiplying at common points. -4 to 3, -infinite to 3. What is the common portion? -4 to 3, -infinite to 3. What is the common portion? -4 to +3 only. Different amplitudes I am having. Unit amplitude, what happens? Different amplitudes I will be getting. Yes or no? Because U of 3 minus n means unit amplitude, no? So this is the result. So, but what is the signal existing from -4 to 3 with the different amplitudes in our case? It is nothing but X of n. So remember here, if you try to multiply X of n with U of 3 minus n, you will get X of n only. X of n only. Or if you have any doubt, below this signal, under this signal, below this signal, you draw U of 3 minus n, and over the common portion you multiply, you will get the same X of n only. You will get X of n only. Yes, Manu, you are right. You are right, Manu. It is same as X of n. X of n only you are going to get. So very interesting discussion we had today. Yes, X of n only. X of n only. Right. So this is about the transformations of the independent variable in discrete, and these are some of the basic signals in discrete. Now let's turn our attention to the next discussion, that is classification of signals. Classification of signals. If you remember our journey, we started with the definition of a signal and we classified the signal based on dimension, and after that we came to a point that for competitive exam we are concerned only with one-dimensional signals in which we have only one independent variable, and we have seen continuous time signals, discrete time signals, digital signals, their representations, interrelationships, the nature of independent dependent variables. After that we have seen what is known as the transformations of the independent variable: time shifting, time reversal, time scaling. And we have seen what happens if you are given combinations of transformations like shifting and scaling. Various methods we have seen. After that we turned our attention to the basic signals in continuous case, where we have seen continuous time unit step, signum function we have seen, An impulse signal we have seen in continuous case, various representations we have seen, and after that we have seen the rectangular pulse, triangular pulse, impulse train signal, and various examples we have solved. After that we have seen the basic signals in discrete. The next topic is what are the classifications of signals. So various classifications of signals we are going to have, and the order in which I am going to follow is, the first classifications of signals is even and odd signals. Even and odd signals. Detailed discussion. Second one, energy and power signals we are going to discuss. Third one, periodic and aperiodic signals. Periodic and aperiodic signals we are going to discuss. After that, causal, non-causal, and anti-causal signals we are going to discuss. After that, deterministic and random signals we are going to discuss. Right? Anyway, these deterministic signals and random signals is not there for electrical students. Electrical students, you can skip the fifth one. But the first four classifications are there for electrical students and instrumentation students also. Right? For EC students, all the 5 classifications are there. So let's start with the first classification of signals, that is even signals and odd signals. So the first classification of signals is even signals and odd signals. Even signals, odd signals. Already told you the definition in the previous topics only. Suppose if I have a continuous time signal x of t, it is said to be even if it satisfies x of t is equal to x of minus t. A continuous time signal is said to be odd if it satisfies x of t is equal to minus x of minus t. Minus x of minus t. What about discrete, sir? Replace t with n. In discrete, x of n is equal to x of minus n. A signal is said to be odd in discrete if it satisfies x of n is equal to minus x of minus n. Sir, can you give any examples? Yes, I can give. Suppose if I take the signal x of t, in continuous case, if I take the signal x of t, what happens if I take the reversal? For this signal x of t, simply take the reversal. Reversal means what? Mirror image along vertical axis. What will happen? You will get the same signal, or this signal can be taken as an example of even signal. Then what about odd signal? Observe here, my dear students. I took a signal like this. Some signal x of t I took. Now take the reversal. Take the reversal for this signal. Reversal means what? Mirror image along vertical axis. So what happens if I take the reversal? It will come like this. 1, this is minus 1. This is x of t. This is x of minus t. What could be minus x of minus t? Already I told you how to draw minus x of minus t also. To the time reversal, take the mirror image along horizontal axis. Is it same as the original signal what I took? Is it same as is minus x of minus t same as the original signal what I took? Yes. So signal which satisfy this property, x of t is equal to minus x of minus t, are said to be odd signals. odd signals. So definition is very important. Even signal means x of t is equal to x of minus t. In discrete case, x of n is equal to x of minus n. Odd signal means x of t is equal to minus x of minus t. In discrete case, x of n is equal to minus x of minus n. Right. Now let's turn our attention to the basic signals what we know. Now, do you know any signals which are even? Starting from the first signal, impulse signal, del t is even signal. Del t is even signal. Ramchandra Rao, I'll discuss about exponential and a complex exponential in a detailed manner, but in the coming discussions. Exponential signal easily you can draw. Don't worry, tomorrow only we'll discuss. Okay. Even signal, del t is an even signal, rect t is an even signal, tri t is an even signal, sampling of t is an even signal, sync of t is an even signal. Yes or no? Impulse signal, del t, rect t, tri t, sampling of t, sync t. Right? Now, can you give any examples for odd signals? Odd signals? Signum t. Signum t is a odd signal. Students, remember, very important. Signum t is odd signal. Verify. Always, if you got any doubt in our subject, verify. Draw. Put pen on the paper. Signum t. What is the shape? This is the shape of signum t. Signum of, take the reversal. Signum of minus t. Right? Signum t, signum of minus t. What could be minus signum of minus t? How to draw, I told you. To the time reversal, take the mirror image along horizontal axis. Is it same as the original signal what I took, signum t? Yes. So remember, signum t is odd signal. Very important point. If anybody asks you signum t is what kind of signal, means it is an odd signal. Suppose if I ask you about ut is what kind of signal? Already we have seen. It is neither even nor odd signal. Neither even nor odd signal. Unit step signal ut is neither even nor odd signal. So these are the very basics. Lot of discussion is there on these even signals and odd signals. Right? And one important point here is, remember, an odd signal must always pass through 0. An odd signal must always pass through 0, or we can say that the value of the odd signal at 0 must be 0. The value of the odd signal at the point 0 must be 0. X of 0 must be 0 for a odd signal. Remember, x of 0 must be 0 for a odd signal. Now if you can observe, what is the value of signum t at 0? What is the value of signum t at 0? 0. How we define signum t? Signum t is 1 for t greater than 0, 0 at t is equal to 0, minus 1 for t less than 0. Remember, an odd signal must always pass through 0, or the value of the odd signal at 0 must be 0. Now you can observe in this one also. What is the value of this odd signal at 0? It must be 0. Or x of 0 must be 0 for a odd signal. So lot of analysis is there regarding this even signals and odd signals. So we are going to discuss all the concepts like anything, but your active participation must be required. Tomorrow's class you will enjoy like anything, right? And let me tell you all the students that on Sunday morning 6 to 9 we are going to have a marathon session in which I'll be giving you 50 problems, 50 small problems which will boost your confidence in basics like anything. All of you must write that exam, right? So this is about today's class. Tomorrow we'll discuss the rest of the things, but before leaving, let me tell you that you can follow me on Unacademy. You can follow me on Unacademy, unacademy.com @kvswamy. My name is Swamy, and I have done some special classes on the app also. You can go and verify, and you can unlock all the free content using the code KVS Live. KVS Live. And these are the channels what we are having in Unacademy. This is our channel Kreatryx, EECIN, and you must propagate this information to other students also, that lot of good information is going to be discussed on the Kreatryx channel. And this is the mechanical channel, this is civil and chemical channel, computer science gate questions, this is also computer science, Unacademy gate English, electrical junction, and the last one is Apti Express. And finally, thank you my dear students, and I'm expecting your active participation tomorrow. And don't miss the coming classes, because if you are going to miss one class means it will become it will trouble you much in the future classes, right? So all of you, those who are coming, please like the session, share the session in all possible ways. Okay, and until tomorrow, happy learning. Don't miss tomorrow's class. Thank you.